Hello, everyone. Good afternoon. We are Group 86, and we are excited to present a project, Pixels to Words, which is a hybrid CNN-RNN approach for automated image descriptions. I'm Udarsh, and I'm joined by Ravi and Navitej. And this project implements a neural network model to help machines describe what they see. To briefly give a quick overview of what we will be covering within this slide or within this presentation, we'd be covering the motivation behind the project and the data set that we used, our model design, training setup, evaluation challenges, and what the future could look like for this project. With that, I'd like to get started with the introduction. Neural networks today are solving a lot of problems which the traditional systems couldn't, like recognizing images, translating languages, or recommending content. But they require good data, responsible usage, and the right compute power. Our application focuses on image captioning, which not only helps with organizing media, but also plays a huge role in accessibility for visually impaired users. So what's the challenge? We basically wanted to build a model that understands the contents of an image and describe it fluently in English, which would imitate our day-to-day communication or language. Our approach combined the CNN to extract features from the images and an RNN to generate captions, bridging the gap between vision and language. Uh, Talking briefly about the dataset, we used a Flickr 8K dataset, which includes about 8,000 real-world photos of people playing sports, animals in action, and more. Each image comes with five different captions, which helps our model learn language variation. It's compact enough for experiments while still capturing a variety of scenarios. Briefly talking about the inputs and outputs, for each image, the model sees the raw RGB input and five accompanying text captions. The output is the new caption, ideally as natural and descriptive as possible. Here's an example where you can see that there's an image and there are multiple variations of the same caption, so that the model is able to learn more about the variation of the language. Talking a bit about the baseline model, we started by creating a baseline pipeline, which helped us set a performance benchmark and let us understand how well a basic CNN-RN model works before diving into advanced concepts such as attentions or transformers. Uh, this gave a clean and minimal setup to learn from. To talk a little bit about the model architecture, our model has two main parts. One being the encoder, where we used a pre-trained Inception V3 model to extract a, 2048 dimensional feature vector, a decoder, which is an LSTM network that takes in those features and learns to predict each word in caption sequence. So a bit about the architecture diagram. Here's how the it's basically a visual showcasing how the image features and caption tokens are processed and combined. The model gives one word at a time, both using image context and previously predicted words. Uh, we train a model with cross entropy loss and atom optimizer. We trained about five epochs with a batch size of 64. That's for systems using CPU. There are a few limitations of the batch size on a GPU-based system, and the epochs could definitely be increased to get a higher result, but we stick with five epochs for now. This can definitely be an improvement in the future scope. And images were resized to fit Inception V3 and captions were tokenized and padded. We used a custom PyTorch dataset to feed the model image caption pairs. Uh, Talking a bit about the model evaluation, we used blue scores to evaluate how closely the generated captions were to human written ones. We observed that the model performed well on grammar and basic object detection, but could be improved when using fine details, likely due to the absence of an attention mechanism. So, as you can see, the captions mostly make sense and describe key objects. However, they sometimes miss contextual depth, like the background or relationships between objects. We implemented several optimizations to train the model faster, and which include cached features for passing images through Inception V3, dynamic padding to avoid unnecessary computation, optimal batch sizing for GPU utilization, data loader prefetching to minimize wait time between training batches. A few challenges that we faced along the way were balancing caption quality with training time and GPU limits, definitely, which force us to use small batch sizes. But the baseline still generated fluently and accurate descriptions, which was promising. Uh, Looking ahead, there are many directions for this project where we can add attention layer to focus on specific regions of the image, swap LSTM with transformers for better sequence modeling, use a bigger data set such as COCO, and try better decoding methods like beam search. We can also package this as an API for accessibility tools, making it usable in the real world. Talking about the prior work, each of us brought some unique strengths to this project. Ravi and Navitej especially focused on the CNN and image classification part of it, while I worked on the sequence generation and language modeling. I'd say combining our efforts helped us experiment efficiently and balance accuracy with performance. Our project is inspired by landmark papers like Show and Tell by Vinels et al. We also learned on survey studies and Kaggle Flickr 8K dataset to build and test our models. Thank you all for your time, and we'd be happy to answer any questions, and we're always open to feedback or ideas on how to take the project further. Thank you.